And we're looking at solving quadratic equations with complex roots. This is very specific examples, things that look like this, equations with two terms, ax squared plus c equals 0. There's no bx. Okay. Before we do things that look like that, let's make it simple. Let's do it with a minus. Okay, so you can see how to solve these ones because their roots are where the curve crosses the x-axis. So you can see already what the solutions will be. But let's go through it. So here x squared minus 1 equals 0. Okay, that's the same as x squared equals 1. So x equals plus or minus square root of 1, which is plus or minus 1. You can see that fits nicely on our graph there, negative 1 and 1. This is of course not the best way to answer this question. Better way is by factoring and then solving. You'll end up with this. You'll skip these two steps. Okay, so there we go, difference of two squares. Let's do this one quickly. X squared minus 9 equals 0 is the same as x squared equals 9, so x equals plus or minus 3. Of course, you can do the same thing with your difference of two squares up here. Okay, so that was nice and easy. This one, because the answers were negative 1 and 1, and here they were negative 3 and 3. So they're like they're pairs, right? Positive and negative. Here, it looks like the same value, but it's not on a nice whole number. So let's see what we can do. Okay, first thing you can do is say, okay, 4 and 32, they've got a common factor of 4. Let's take that out. Okay, now let's make that into x squared equals 8. So x equals plus or minus square root of 8. Square root of 8 has a square factor. Okay, 4. 2 4s are 8. So we can change square root of 8 into 2 root 2. So this is negative 2 root 2. This is positive 2 root 2. Okay, so hopefully you're familiar with all of that, with the difference of two squares, with solving by graphing, and with the simplifying the square roots over here. If you can do this, now we can approach complex roots. You see, in these three examples, the graph isn't crossing the x-axis. Is the x-axis? It isn't crossing the x-axis. Okay, so what we can do is do the same thing we did before. Not got difference of two squares, so we can't factor it, but we can say x squared equals negative 1 here. Okay, so x equals plus or minus square root of negative 1, or plus or minus I. Okay, so it's got imaginary solutions, no real solutions. Let's check this one. Okay, again, x squared plus 9 equals 0, so x squared equals negative 9. X equals plus or minus square root of negative 9, which of course is 3i, so x equals plus or minus 3i. Okay, like before, this third example, we can factor the 4 out, then take the 8 over the other side, or take 8 from both sides, and then simplify to an imaginary number. Okay, so you see with each of these three examples, we end up with an imaginary number. And it's a pair of imaginary numbers, right? I and negative I, 3i and negative 3i, 2 root 2i and negative 2 root 2i. Okay, you got perfect pairs here, as on the last screen too, because we're right on the x-axis, right? Our vertex, y-axis. Our vertex is on the y-axis, or the line of symmetry is the y-axis. For other quadratics, like this one, where the vertex is not on the y-axis, you're going to end up with not just an imaginary number, but a complex number as your root. And to do this, you're going to have to do completing the square or use a quadratic formula. So you can look at my other videos to see how to do that, but we're going to do that later. All right, so going back. So solving these should be pretty straightforward now. Good luck with that.